Kamala, thank you very much for that. Because I'm not a cooker, so that's why I don't know. Okay, any roast, cook. Okay, cook. If you want to cook amala and you place your water on the fire and you wait, but this water remain the same. That is not boiling, and you've been waiting for maybe like 30 minutes. You've not seen this water boiling. Okay, who can tell me what we do in our house to make the water boil fast if you want to cook amala? What do our mother, have we experienced that before? Okay, who is that person?
So they'll put some powder on the water.
They will put powder. What kind of powder?
Like the amala
The yam
powder.
flour, right? Okay,
Yes.
that's fine. Any other opinion? As I like you, you live in the village.
No.
Okay, that's fine. Okay, okay. Any other person? Okay, someone said we will increase the temperature of the fire. I didn't mean we've increased the temperature of the fire. Maybe it's not boiling up to that extent. Okay. What's the next thing? Someone said you are going to put powder. Someone said we should increase. No. So, okay. I didn't mean you've increased it up to that level, up to the normal level that it should be. The next solution that they are going to do while we are still young is that they are going to pour powder, yam powder, or yam flour powder on top of the water. So our mothers, they see it as when you pour it on it, it will make it faster to what? To make the water to boil quickly. So fine. So we can use that as a catalyst that it helps us when we pour it on it, it helps us to what? To increase the boiling point. It helps us to increase what? It helps us to increase how boiled the water will be. Are we together? So does it add to that? So what they say is that in that case, we can actually say it acts as a catalyst. It helps us to speed up the rate of that reaction. Are we together? Are we together? So likewise, another example I could give in your physics. If you are doing linear expansivity, you are going to do temperature, the volume, area expansivity, linear expansivity, and so on and so forth. Why doing it? They are going to tell you when we are, I don't know if you've heard about viscosity before. Viscosity. Okay, the viscosity, normally they do call it fluid frictional force. What do I call it? Fluid frictional force. Okay, let me just use this as an example. They will now tell you that when salt is added to a water, it does not increase the boiling point. But when you add sugar to it, it will make the boiling of that water to be very fast. Normally, in our chemistry, they told us that we have pure substances and we have impure substances. When we said impure substances, it means a mixture. Why pure substances means that we don't mix anything to it. That actually it makes it what? When you boil that pure water, that you don't mix anything with it, it will boil faster than when you mix something to a water. Actually, in chemistry, it is correct. But in other real practical life, they don't assume it as what? As something that is correct. That until you add substances to it, like the powder that we said, so it will serve as a catalyst, which speed the rate of that chemical, the rate of the what? Of the chemical reaction. I will give us example that is very similar. Okay, when you have during Ileya, we are going to buy ram and we are going to slaughter it and cook it, right? Okay, and you want to cook it. Someone who use petrol and someone who use what's it called, kerosene. Someone use kerosene. That's the first person use kerosene to what? To remove all the what? All the air in the what? In the body of that ram. Okay, compared to the other person that uses oil with petrol together, mixture of oil with petrol, and pour it on the body of that what? On of that ram. Okay, we want to arrive at the same point that we want to remove the air from the what? From the animal, right? Which one will it fast? Which of the reaction will it fast? Is it that of the kerosene or that of the oil with petrol?
Oil with petrol.
Oil with petrol, fine. What has happened in that case is that you use oil with petrol so as to fasten the what? That reaction to remove the what? The air from the what? From that animal faster than compared to that of the what? That of the kerosene. I don't think we get it right. So it does not change anything on it. We are still arriving at the same thing. So if you wash it very well, you won't smell anything from the body of that animal, right? So what we've done in that case is that we just use kerosene with oil to faster or to speed up the rate at which the air from that animal would be removed, and that of that kerosene out together. So in that case, that's the process of catalyst. We can actually do it without pouring anything on the animal, neither petrol nor oil and kerosene. Are we together? So, but in this case, we just want it to be fasting. We want to speed it. So that's why we are using what? We are adding something to it. Another example, your banana. When you have unripe banana, when you put it in your house and you expose it to the atmosphere, who can tell me what will happen? Will it ripe? Will it ripe?
No.
No. But what can you do to make it ripe?
You wrap it.
Wrap it.
You wrap it, right? When you wrap
Yes.
it, you wrap it with what? You either wrap it with what? With
Nylon or
cloth.
cloth.
With
Yes.
clothes.
Yes, exactly. When you wrap it, you know that it will make it what? It will make the reaction to be faster, right? But
Yes.
for those people who are selling it, they don't wrap it with what's it called? They don't wrap it with clothes, neither clothes nor nylon. Who can tell me what they use?
They use
Sun.
banana leaf.
They use banana.
Leaf.
Okay.
Maybe
What else?
they put it under the sun.
Under
They
the
usually
sun.
put it in a dark
No,
room.
no. They put it with what?
They usually put it in a dark room.
In a dark room. Fine. That's fine. I said, okay, they put it in a dark room so that they prevent it from exposure to what? To air. That's fine. That's why they wrap it as well. So that's what they want to do. Okay. For that, there is still something. Someone said they put banana leaf inside it. Okay, when you have that banana, those people who are selling it, when you wrap that banana, it can take up to 4 or 5 days before it ripe. Is that not so?
Yeah.
Yes, sir.
Yes.
But those people who are selling it, will they go with that process? They are selling
No.
it for the livelihood.
No, sir.
Who can tell me what they do, what they use to make it fasting?
They
Yeah.
use Cambad or
No, sir.
Cambad. Someone said something. Cambad. Thank you very much. They call it Cambad in Yoruba, but it is Carbide. They make use of what? Carbide.
Carbide.
Yes. That Carbide we fasting it maybe like a day. It will have ripe. Are we together? Does that carbide add to what? Add to that banana?
No.
No, what they use it to do is that they use it to fasten the rate of the reaction.
The wiping.
They use it to fasten the rate at which that banana will be what? Will be ripe.
Right.
Put it together. So that's the word. I just use that one as a major example for catalyst. I think we get it right. Like the person that said there are some people that use banana leaf as well, that they are going to put it inside, but majorly they make use of what? Carbide, so that it will fasten the rate at which it will be right. That's the good example of catalyst. It fastens the rate at which you to run. So that's what we call catalyst. So under that, we also have what we call catalysis. Catalysis. So catalysis, when we said catalysis, what means by catalysis? Catalysis is just that substances, the substances that remain unchanged at the end of the reaction. That's this what we call catalysis. Is that substances, catalyst is something that we add to a reaction to make it fast. Are we together?
Yes, sir.
Okay, let me just use that as an example. Okay, for the banana and that of the carbide that we said, carbide is a catalyst that speed that reaction. Are we together? But the catalysis is that banana. Huh? I don't think you get it right.
Yes, sir.
Yes, catalysis. So it's just that substances which remain chemically or quantitatively unchanged. Banana does not change from banana. It does not change to anything. What changes that from unripe to what? To ripe.
To ripe.
But it does not change from banana. So that banana, which we said, is that these substances which remain chemically or quantitatively unchanged at the end of the reaction is known as catalysis. Is known as what? Catalysis.
Catalysis.
That's why I'm breaking it down for you so that you guys can understand what we mean by catalysis. So now, under catalysis, we have what we called catalytic reaction. What do I call it? Catalytic reaction.
Catalytic reaction.
You know that the banana is what we call catalysis, Abby. So under that catalysis, there are two types of catalysis. There are two types of catalysis. Two types of what? Catalysis.
Catalysis.
We have number one, we have homogeneous. What do I call it? Homogeneous.
Homogeneous.
Yes, we have homogeneous catalysis, and we have number two, we have what? Heterogeneous catalysis. Now, what do I call catalysis for you? I said that reaction, that substances, right?
That they are catalytic.
Yes, the substances that undergo that catalyst is meant to is called catalysis. Is that not so?
Yes.
Thank you very much for understanding that. So, for example, when we said homogeneous catalysis, not homo. Homo means the same. Homo means what?
The same.
That is the reaction, the state of that reaction remain the same. Remain what? The same. We have the state of matter. How many state of matter do we have in chemistry? We have the solid, we have the liquid, it's not liquid, gas. What else do we have? The state that you have in chemistry. We have gaseous. Or what do you call it?
Gaseous.
Aqueous solution. So we have solid, liquid, gas, and aqueous solution. These are the state that we have. But when we are talking about the homogeneous catalysis, in that reaction, the state of that substance we have still remain the same. It remains what?
The same.
So it is the same with that of the what? With that of the catalyst. With that of the what? Catalyst. I will give you an example of homogeneous. Let me just give you an example. This is an example of homogeneous. when you have SO2 plus O2 gas and gaseous liquid, which later gives us it later gives us two SO3 gas. So in the presence of NO2 gas, okay, sorry, let me just write it so that it will be clear, which gives us, in presence of NO gas, give us 2SO3 in gaseous state. So the first thing is that we need to see if the reaction is balanced. How many sulfur do we have here? We have 2 sulfur, right? Here also we have 2 sulfur, right?
Sir.
Oxygen that we have here is 4. 2 times 2, 4. Oxygen that we have here is 2. That's 4 plus 2 makes what? 6. 2 times 3 here, 6, right? The reaction is balanced, right? So now, what do we now call homogeneous catalysis? Homogeneous catalysis is that when both the reaction, you're not seeing my screen. You need to log out and log in, please. Are we all seeing it? Others, are we seeing this?
Sir.
Can we see the
Yes,
screen?
sir. Yes, sir.
So please, my sister, please log out and relog in. Sorry, I don't know if you are a sister or brother. So, okay, what's your question? You have a question? Odwola so much. Odwola, sorry. Do you have any question? You raise up your hand.
No, sir.
Okay, put your hands down, please. Okay, that's fine. Okay, can we see the screen perfectly?
Yes, sir.
So now we can see that in this reaction, both the reactant and the product side, all the states that we have here, they are gaseous states, right? Both the reactant and the product, right? We all have gaseous state, right? Now, when you now check the catalyst, this is the catalyst, this is where catalyst is. Can you find NO in this reaction, both the product and the reactant side? Can you find it there?
No.
No, we cannot find it there. That's the work of catalyst. So now in this case, NO gas, yeah, you know, you will see that it is also in gaseous state as both reactant and the product side. So it means that the state of both the reactant and the product together with the catalyst are the same. So far, all of them are the same. We call this type of reaction as homogeneous catalysis. What do I call it? Homogeneous catalysis.
Catalysis.
When do we now have heterogeneous catalysis? Is when the reactant, the product, and the catalyst are in different phase. I don't think if you guys get it. The word hetero, it means different. What do I call it?
Different.
Yes, different. So homogeneous means the same. That is, in homogeneous catalysis, the reactants, product, and the catalyst are in the same, have the same what? Have the same phase. Are we getting it now? So, but when we said heterogeneous, it means that the reactant, product, and the catalyst, they are in what? In different what? Phases. I think you get it right. So I'm going to give you one example. Okay, I've written this. Please let's write this. Let's put it down. We've written it right.
No.
Yes, sir.
Well, let's write it, please. Okay, are we done? I think we should be done with that too. Okay. So, example of heterogeneous catalysis. You will see that in heterogeneous catalysis, what do we say? We said what? In heterogeneous, what do we say? We said both the reactant, the product, and the what? And the catalyst. And in what?
And the catalyst.
And
In different ways.
cases. Yeah. So that we have, if we have N2 gas, plus, you see that, do we all know ABA process? What is ABA process? Who can tell me ABA process?
It's the process of manufacturing ammonia.
The process of manufacturing ammonia. Oh yeah, give me, what is the reaction for ABA process? You know, they won't ask you that, what is ABA process? They will just tell you that, okay, what is the logic behind ABA process? They will just ask you, what are we mixing together?
We are mixing nitrogen and oxygen.
Nitrogen and oxygen.
Yeah.
ABA process.
Yes, sir.
Nitrogen and oxygen.
Yes, sir.
Are you sure? Nitrogen and oxygen.
Nitrogen and hydrogen.
So okay, nitrogen and hydrogen.
I'm sorry, nitrogen and hydrogen.
Addition of nitrogen and hydrogen.
Yes, nitrogen
and the addition. So let me just define ABA process for you so that you can understand. ABA process is the process by which one molecules of nitrogen gas is added with 3 molecules of hydrogen gas to yield 2 molecules of ammonia in the presence of finely divided ion. In the presence of what?
Finally divided.
Finely divided ion. So that's what we call ABA process. ABA process. What's ABA process? HABAL, ABA process. So that's no. What's the ABA process?
HABER.
Yes, BER, ABA process. Thank you very much. So this is ABA process. So in the presence of finely divided ion, so ion that is here is solid. So what they use as an example of heterogeneous catalysis is ABA process. What do I call it? ABA process. This is ABA process. When 1 molecules of nitrogen gas reacts with what? 3 molecules of what? Hydrogen gas to yield what? 2 molecules of ammonia gas. In the presence of what? In the presence of what?
ABA process.
In the presence of ABA process.
No.
In the presence of
ion. Finally divided ion.
in the presence of
finally divided ion.
Yes. So now when you check this, you will see that the reactant, we have gas, and the product gas. But something is changing. Our catalyst is in what? Is in solid form. These has changed. So that shows that if they are in different phases, it means we are talking about what? Heterogeneous catalysis. If any of the product, reactant, or catalyst change, it has turns to what? Heterogeneous catalysis. Are we together?
Yes, sir.
I think you understand, right?
Yes, sir.
So I'm going to write one reaction for you. You are going to tell me whether it is homogeneous or heterogeneous. Are we together? So
yes, sir.
If we have H2 gas plus I2 gas, which give us two molecules of hydrogen iodide. So in the presence of the platinum, so now, is this homogeneous catalysis or heterogeneous catalysis?
Homogeneous
Homogeneous catalysis.
catalysis.
Homogeneous catalysis, right?
Yes, sir.
Yes, sir.
Can we see it very well? Let's check the reaction very well.
Heterogeneous.
Who said heterogeneous?
Homogeneous.
Aisha, right? And Amina,
Heterogeneous.
it is heterogeneous. Why? Why is it heterogeneous? All of the
It is.
phases, both product and reactant, they are in gaseous state, but the catalyst change to what? Solid. So
Solid.
this is heterogeneous catalysis. Are we together?
Yes, sir.
So I think we are fine with that. So that's fine. So that's the differences between that. So based on the reaction, you have heterogeneous catalysis and what? Homogeneous catalysis.
Homogeneous catalysis.
Yes. Now, it now leads to characteristics of catalyst. If you know characteristics of catalyst, they alter the rate of chemical reaction. That is, they speed up the rate of chemical reaction, and they remain unchanged. Number two, they remain unchanged at the end of the reaction. That's what you know. And just go and check, please. Go and check the characteristics. So now it now moves. We need to move to the types of catalysts that we have. The types of catalyst. We have positive and negative catalyst. What do I call it?
Positive and negative.
Positive catalysis.
We also have promoter and inhibitor. What do I call it? Promoters and what? Yes. So that's what we have. So I'll just give you what you need to know, types of catalyst. And you need to know that we have what we call enzymes. Do you know enzymes? Enzymes. Who can define enzymes for me? Enzymes. Yeah, let's talk, please. Enzymes.
They are biological catalysts.
They are what? Biological catalysts. That shows that enzymes should be part of what? Oh yeah, they are biological catalysts. Oh yeah, which what? So the types of catalysts we have.
Of chemical reactions in living cells without being used up.
You're too fast.
You did not know it's me.
Yes.
Yeah, please define it once again for us. They are biological what? They are
Catalysts,
biological catalysts.
which speed up chemical reactions in living cells
They are biological
We
catalysts.
speed up chemical reaction in the living cells
without being used up.
without being used up. My brother, do you add what she said now?
Yes, sir.
Yeah, promoters and inhibitors. So these are the type of catalysts that we have. So are we together?
Yes, sir.
Ibrahim, don't do
Who is
Ibrahim?
I'm sorry.
Okay, no problem. So when you said positive and negative catalyst, that shows that when you will have positive catalyst, you will see that it will increase the rate of reaction. Is that not so? That's why it is positive. It means it will increase. What of negative? What will negative does now?
It should decrease.
Negative catalyst decrease the rate of chemical reaction. Someone has defined enzymes for us. Enzymes are organic catalysts and they are biological catalysts. Exactly. So as my sister said, so what does the main work of the enzymes? Enzymes, the work is that it helps us to digest the food we eat. Enzymes, it helps us to what? Digest the food we eat. So having been you've done digestion in your, what's it called? In your biology, you will see that
Yes,
you have part of the food that you have in your this thing, you have the carbohydrates, you have the protein and the likes and the likes. So now they from what biology taught us, they said that when you are eating carbohydrates, carbohydrate is being digested in your mouth, not in your stomach. The first digestion of carbohydrate is from your what? From your mouth, because you have what we called thiolin below down your ear like this. We all know thiolin from our saliva?
Yes, sir.
So this thiolin help us to break down the carbohydrate into maltose. Into what? Maltose. So is what we know. So, but the protein that we do eat, protein does not break down in our mouth. It breaks down in our stomach because we have two enzymes in our stomach. What are the two enzymes we have in our stomach? We have the renin and what? Renin and what? Let's talk now. The two enzymes that we have in our stomach that help us to break down our protein.
let's see.
We have the renin and pepsin. And don't forget that we have renin and pepsin. Don't forget that we still have hydrochloric acid inside our stomach. Is that not so?
Yes, sir.
Yes.
Yeah. This renin is an enzyme. You will see that when we talk about enzymes, it helps us. What enzymes does is that it helps us to digest the food we eat. So now, enzymes like renin, when you eat your protein, that's why too much of protein will cause problem to your stomach. So because too much of that protein, too much of beans will cause problem to your stomach. And yes, exactly. Everybody experience it. Or none of us has experienced that. None of us. Okay. You know that we've experienced it. So when you eat too much of and without stopping it, so it causes problem to your stomach. Yes, because the renin, which is an enzyme, it acts on milk. It acts on what? It acts on what? Milk. So why pepsin help you to break down protein to pepsinogen? Protein to what? Pepsinogen. Are we together? So that process, what the hydrochloric acid that you found in your stomach, it provides an acid medium for that two enzymes. What does it provide? An acid medium for the what? For the two enzymes, which is the renin and that of the what? Pepsin. Are we together? So it means that we need to understand all these things very well. And when you understand your biology together with the chemistry, it helps you a lot. So it helps you a lot too. So that's the work of the enzymes. So after that, we have the promoters and inhibitors. So promoters, when you add the word promoters, so what they do is that they are not just catalysts themselves like that. What they helps is that they influence the rate of chemical reaction by affecting the efficiency of the catalyst. So there are some textbooks, they do call the promoter. When we said promoter, it helps us to promote. Inhibitor, it inhibits the process. Are we together? That's so that it is, they don't see them as catalysts. What they see is that when promoter and inhibitors, when they are present in a reaction, they help us to influence. They influence that the rate of chemical reaction. You will see it. we are going to reach there. The rate of chemical reaction. When you are doing the rate of chemical reaction, means in chemistry is that is the what is the change in the product of a substances with time. With what? With time. So yes, I will use this as an example. Okay, for example, in chemistry, while we are in 300 level, we did the chemistry, food chemistry. So in that food chemistry, we did the rate at which food decay. The rate at which what? Food decay. For example, when you place, what's it called? You place your eba, you cook eba now, and you now put it down. There is what? There is exposure to air. After 3 days, what do you think it will happen to that eba?
It will spoil.
It will spoil. Is it? Will it spoil? That's why you do not live in the village. Oh. We do eat 3 days eba in our village.
Really?
3 days ago.
Yes, now.
Thank you very much, my brother. You live in the village very well. So in the village, we don't eat 3 days eba. Hey, this one is crying. See, what happened is that during that time, when they cook eba for you, this eba is what you are going to eat in the first day when there is much eba, because that time the amount they are selling gari is 5 naira. Sometimes they do sell, when I think 2011. So in 2011 we do bought rice 20 naira 2011. So the amount that are selling gari for us then, this one 2011 we do buy rice 20 naira. That's because my mom is selling rice then. So the gari at that time, ma,
Is it bag of rice?
no, 1 cup of rice. 1 cup of rice is 20 naira. The bag of rice then is 6,500 naira. Yes.
Wow.
1,500.
6,500 naira is the bag of rice
Wow.
then, 2011. So we do take it from Shaki. Shaki then we bought it 5,500 naira bag of rice then. So now, so during that time they are selling gari for us. That bread that you are buying 300 naira, 400 naira, then we do buy it 15 naira. They do call it Kumamejiabo.
15 naira.
15 naira, yes. They do call it Kumamejiabo then. Kumamejiabo. That's Kumamejiabo. That's 5 naira. Kumamejiabo is 15 naira. So Kumamejiabo, that's 7.5. That's 2 naira in 7.5. Meje is 7. Abo is 0.5. That's 7.5 times 2. That's 15 naira. That's the bread that you are buying now. So, and gari then is 5 naira per cup. So 5 naira per cup, and they can sell cup for us 15 naira. Yes, in 2010, 2011. Yes, if I could remember. Yes, that's the amount that they do sell it.
Yes.
So now when they now cook eba, there is surplus of gari that time. So they will cook a lot of eba for us. And after we've eaten the one we can eat, so we do cook it with obeila, ilala sekbo then. So after we've eaten the one that we can eat that time. So what they will just do is that the rest, they will just keep it for us. The second day we might not eat it. The third day they will bring it out for us to eat. And what will have changed? Yes, what will change there is that it will just form some foamy on top, and our mama and our baba, they will just remove the foam on it, and they will put hot ewedu on it. So that's during that time, the rate at which that food decay is very, very small. Before food can decay, at that time, we have to be very, very minute. Do you understand? So very small before the food. So at that particular time, the rate at which food decay is very, very small. That's why, so there is nothing to inhibit it. But now, if you want to inhibit it, yes, it's sweet, honestly. It's sweet a lot. Oh,
Asao.
Abina.
who said that? Because you, it's always sweet. Don't worry. So it's always sweet. So, but today, due to the fertilizer that they used to do this garden nowadays, because they want to increase the rate at which they were selling it. So, Benny Beck or what's your name? Please, meet your mic, please. So we want to round it up now. So I want to round it up with the promoter and the inhibitor. So at this point in time, what we do is that, and we eat it and we enjoy our life. But nowadays, if you can keep that eba for 3 days, something will have happened to that eba due to the chemicals that they use in that guy. We understand now. So that is exactly what happens. So now, what do you use to promote those things? Is that you put it in your microwave? Is that not so?
Yes.
Those things that you want to keep, you put it inside the freezer. We don't have freezer then. There is not much freezer. What we have then is fridge. The fridge. Yes, we don't have freezer. We have fridge then. The fridge is those big ones. They are tall. The tall fridge is what we have. Olaiwola said yes. Who is Benny? Adeniyi, please help us to mute your mic, please. Okay. So that's what we use. That's what we use then. So we use the fridge. It is tall like this, not that of the freezer that we have nowadays. So we don't keep anything there than water. We don't keep our food there. We don't do so. But nowadays you keep your food inside the fridge, your meat inside the fridge, or everything. But then we don't have where to put it. So that's how we enjoy our life then than today. So that's the promoter and inhibitor that we use nowadays. So that's all. So in our next class, we are going to continue. Thank you very much for coming to the class. So let's go and read thermal dissociation. So we are going to start with oxidation and reduction reaction in our next class. Oxidation and reduction. So, and reversible reaction. We all know the reversible reaction. Reversible reaction, what matters in reversible reaction is that we have two reactions then. We have the forward reaction and what? And backward reaction. That's so that the reaction can move from reactants to product and from product back to what? To reactants. Yeah. Example is your what? Is your ice water. When you have ice water, when you eat that your ice water, it becomes ordinary water. Is that okay? And when you when you freeze that ordinary water, it turns to ice back again. So that's reversible reaction. So it can move from forward, from backward to forward, and from forward to what? To backward. That's reversible reaction. Thank you very much for the class. So I really appreciate your cooperation. Thank you very much. Any question? Any question? No question. Thank you. Goodbye. Take care of yourself.
Ramadan Kareem.
What will be my response when you said Ramadan Kareem?
Same to you.
Same to you. Okay. Ramadan Mubarak. Someone said that.
Yes.
Are we doing the layer of? No, it's not Eid. So Ramadan Mubarak, Ramadan Kareem. So Barakallahu fikum. All right. Assalamu alaikum.
وعليكم السلام.
جزاكم الله خيرا.
جزاكم
Wa
الله.
jazakumullah khair. Thank you very much. Wa jazakumullah khair. Bye.
Bye, sir.